Good evening, teachers, parents, and all the wonderful students. Welcome to Pusat Tuisyen Academy YouTuber. Bermula percuma, selamanya percuma. How are you doing today? I hope all of you are ready for today's lesson. Before we proceed, let's begin our session by reciting a prayer for Muslims. The non-Muslims may pray according to their own religions. Let me introduce myself. I'm teacher Lau from SMK Tinggi Krang, the moderator of the day. We at Pusat Tuisyen Academy YouTuber will provide you with free online classes. Let's take this opportunity to do your revision. So are you ready? Let me introduce our teacher for today's lesson. We have Cikgu Shahnon from College Matriculasi Pulau Pinang. We are now live on Cikgu Shahnon's channel. Please support his channel by clicking subscribe now. The topic of today's lesson is Alkane, and together with us, we also have Teacher Kong from College Matriculasi Perak, who is control host, in charge ensure the smoothness of our lesson on technical support, and Teacher Tang from College Matriculasi Selangor is observer to ensure the smoothness of our lesson. So before we begin, I have a few reminders to all of you. First, please pay attention to our lesson. Use the chat session wisely. Then regarding the certificate link, the link will be given at the end of our session. You can use a MOE account when you fill in your particulars, and make sure to listen to the passcode given by me during the lesson, and fill in the form within the time limit, which is 30 minutes. So I will give you the first 3 passcodes for today. So it's A18. I repeat, A18. So without further ado, let's welcome Cikgu Shahnon.
Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Welcome to Kimia Prayu. Alright, this is my poster, and before we start, as usual, I try to introduce myself. My name is Shahnon from College Matriculasi Pulau Pinang, and teaching experience about 21 years. And my channel is www.youtube.com/c/Shahnon channel. And this is our team, Kimia Prayu. We have a teacher Vivi Lau as our moderator today, teacher Tang as observer, and myself, Cikgu Mawar, and teacher Kong as a moderator. And here is mathematics. We have a teacher Im as a ketua panitia, and also we have biology Prayu, STPM and matrikulasi, lead by Cikgu Faizah, and then perakaunan dan ekonomi Prayu, lead by Madam Fizi, and last but not least, physics STPM Pra University, lead by Madam Rosmaya. And don't forget to serve Academy YouTuber portal at www.academyyoutuber.com. All right. And our topic today is alkanes, and our objective, number one, is define hydrocarbon compound, because alkane is a kind of hydrocarbon compound, and then classify hydrocarbon into aliphatic, aromatic, saturated, and unsaturated. And the last one is draw the structures and name the compound according to IUPAC nomenclature for straight change, branch, alkane, cyclic, alkane, and alkyl group. All right, let's begin. Okay, what is hydrocarbon? Hydrocarbon are organic compound containing only carbon and hydrogen atoms. For example, we have methane, okay, methane CH4. This is kind of alkane. And then we have alkene. For example, is ethene. The molecular formula is C2H4, and alkyne. Okay, ethyne, C2H2. As we can see, only carbon and hydrogen. So all of them are hydrocarbon compound. And benzene, okay. Benzene also C6H6. This is arene. And in a schematic diagram, we can divide hydrocarbon into two, as I mentioned before, saturated and unsaturated. And for saturated, contain only carbon-carbon single bond. An example of saturated hydrocarbon, alkanes and cycloalkene. And for unsaturated, contain at least one carbon-carbon double bond or triple bond. For example, is alkenes and alkyne, right? Okay. Okay. If we want to look deeper, for example, saturated and unsaturated. For saturated hydrocarbon, only alkanes and alkenes and alkynes, they all of them categorized into aliphatic. All right, aliphatic. So in aliphatic compound, we have alkane, we have saturated and unsaturated, which is alkene, alkene, and alkyne. For arene, arene is categorized as an aromatic compound. Okay, and then okay, alkanes. Now we go to the alkanes. Alkanes are saturated hydrocarbon, okay, which contain only single covalent bond. And general formula of alkane is CnH2n plus 2, where n start from 1, 1, 2, 3, 4, and so on. Okay, this is a general formula of alkane. And each carbon atom in the molecule is bonded to 4 other atoms by single bond in the form of tetrahedron. Okay, and each carbon in alkane are sp3 hybridized. Okay, sp3 hybridized. Okay. Oops. Okay. This is a name and the structure formula and molecular formula of alkane. And I'm sure all of our students here already know all the 10 names of this alkane. Okay. Start from methane with one carbon, methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. Okay, the structural formula is CH4 for methane, and ethane is CH3, CH3. This is structural formula in form of condensed structure. Okay, as you have learned before, um, organic compound we can draw in three types: condensed structure, expanded structure, and skeletal structure, right? And this one is written in condensed structure. For molecular formula, CH4, C2H6, that is molecular formula. But in organic, um, we um, we prone to write or draw the structure in structural formula, whether it is in condensed structure, expanded, or skeletal structure. Okay, all right. And then, okay, this one is interesting. We call it substituent. Okay, we call it substituent. Table show the list name and the structure of various alkyl group or substituent. We have a CH3 dash. Dash mean the the group of atom here CH3 attached to what we call main change. Okay, main chain. For example, we have a main change butane, for example, and this CH3 as a branch we call it substituent attached to the main change of hydrocarbon. Okay, so the CH3 here, uh, it has a name. The name for CH3 is methyl or methyl. Okay, methyl or methyl. And then for CH2, CH3, the name is ethyl or ethyl. Okay, methyl, ethyl. Actually, methyl come from methane. Okay, methane. That's why all of them we call it is as a alkyl. Alkyl is from alkane. Alkane, alkyl, alkyl, alkane. Alkyl means we remove one H of alkane and attach to the main change of hydrocarbon. Okay, so that's why the name here is alkyl or alkylate. I want to draw something here. Highlight. Okay. Okay. Alkyl. This one. Okay. Alkyl. CH2, CH3, ethyl came from ethane. Okay. CH2, CH2, CH3, propyl. And for propyl, it has, I can say that it has isomer. Okay, isomer because it has same number of carbon and hydrogen. Okay, if you look at the number of carbon is C3 and the hydrogen is 3, 4, 5, 6, 7. Okay, so propyl or propyl, CH2, CH2, CH3. But isopropyl, it has a branch. CH, CH3, CH3. Okay, so three carbon, we know that three carbon is propane, and for propyl, it has two different type of propyl and isopropyl. All right, ethyl only one, methyl only one methyl, only one ethyl. But for propyl, it has two type of propyl, isopropyl and propyl. For butyl has four type of I call it isomer. The first one is linear butyl, CH2, 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 CH3. We call it butyl. Sometimes we put it N. Where is my pen? Okay, yeah. Okay, sometime. Oh yeah, N, yeah. Okay, sometime um, the name of linear butyl is N-butyl. N actually stand for normal, no branch. Okay, N-butyl. All right. The second one is isobutyl. If you look at this isobutyl, the structure is same as isopropyl. Okay, this one. It has a branch like this, but we just add another CH2. Okay, another CH2. So this is isobutyl. Okay, we have a butyl, we have a isobutyl, and then we have a sec butyl. This one is sex butyl. Isobutyl, the branch here at this carbon, but now we change the branch to this carbon. We can say that this is carbon number 1. Okay, like this. Okay, for this one, the branch is at carbon number 2. Okay, for isobutyl. For sec butyl, now the branch CH3 at carbon number 1. Okay, number 1 from near to the uh, main main what uh, main hydrocarbon. Okay, so we call it sec
Parent
butyl.
change.
Parent change, yes. Okay, thank you, Teacher Kong. Okay, with the parent change here, we have parent change, and this is substitute. All right, near to the parent change, the carbon is carbon number 1, number 2, and number 3, and we have a branch. the branch attached to the carbon number 1, and this is sec-butyl. Okay, the sec-butyl here actually stand for secondary. If we look at carbon number 1, the carbon number 1 is a secondary carbon. Okay, maybe because of that, the name is sec-butyl. Okay, sec-butyl, because it has 4 carbon, 1, 2, 3, 4, and the carbon number 1, okay, carbon that directly attached to the parent change is has a branch, okay, secondary, okay, sec-butyl. And the fourth one is third butyl, okay. This is because if you look at this carbon, okay, the carbon that's directly attached to the main change or parent change is tertiary carbon, all right? So in four carbon as an alkyl, we have 4 types of butyl, okay? Butyl or N-butyl, isobutyl, sec-butyl, and third butyl. All right. Now we go to pentyl. Pentyl, we have a 5 carbon. Okay, number 1, of course, without branch, we have a linear pentyl, so we call it pentyl or N-pentyl. Okay, N-pentyl. The second one is isopentyl. This one is isopentyl. Okay, same as the branch there, same as isobutyl and isopropyl. Okay, isopropyl. Okay, and the third one is neopentyl. Okay, we call it neopentyl. Okay, this is neopentyl. This is carbon that is directly attached to the parent change, and we have one the carbon here actually is quaternary carbon. Okay, the quaternary carbon here. So the name for this is neopentyl. Actually, it's come from this structure. This structure CH3, 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 and CH3. Okay, this is the structure. Name for the structure is neopentane. Neopentane, and neopentane is not IUPAC name. It is a general name, and the name is very popular. So neopentane, and when it's become alkyl, so they just add. So they just the pentane there is become pentyl. So the substituent become neopentyl. All right. So in this case, we have how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 11 name of substituent that you have to memorize. Okay, you have to know the structure. You have to know how to write the structure uh, exactly as what as I showed. Okay, and then we also has for cyclic alkene that become alkene. We just the name is if this one is not a substituent, this is cyclopropene. So when it's become substituent, cyclopropyl, something like that. So we have a cyclobutyl, because if it is not a substituent, the name for the structure is cyclobutane. When it's become substituent, cyclobutyl. Okay. All right. Okay. Now we go to how to name the branch alkene. Branch alkene. Branch chains alkane are named according to the following rule. Okay, rule number 1. Rule number 1: identify the longest continuous chain as a parent name. Okay, as a teacher concept, parent change, right? Parent change. Sometimes we forgot. Okay, for this one, we have to identify the longest continuous change, and the longest continuous change is 6. 1, 2, 3, 4, 5, 6. So the parent's name is hexane. Okay, this is rule number 1. Very easy. Try to find the longest continuous change as a parent's name. Okay, and don't worry, we only will give at least the longest continuous change. The limit for the longest continuous change is only 10. Okay, not more than that. Okay, not more than that, because in our syllabus only 10 decade. All right. Okay, for this one, um, 1, 2, 3, 4, 5, 6, like that, octane. Okay, um, if your um uh 1, 2, 3, 4, 5, 6, okay, like this. Oops. Okay, if your counting is 1, 2, 3, 4, 5, 6, that's wrong. All right, that's wrong, because that's not the longest continuous change. The longest continuous change for this structure is 8, and the parent's name is octane. So I always say to my student, uh, I always say that this is jalan yang lurus, right? Sometimes jalan yang lurus itu adalah jalan yang salah, right? Okay, don't. Where's my eraser? Okay, this one is eraser. Okay, you have to very careful, because sometimes we have jalan yang berliku, yang berliku. This is actually the right path. Okay, where is the purple? Okay, okay. The parent's name for this structure is octane, because the longest continuous chain is 8 carbon. Okay, rule number 2, name the substituent and always give a smallest number, smallest, not smaller, smallest, should be the smallest, to the substituent. For example, this one, 1, 2, 3, 4, 5, 6, and our substituent there is at number 2, not number 5. Okay, because we try to give the smallest number to the substituent. So the smallest number to the substituent is number 2. Okay, and we already know that CH3 is methyl. So the position of methyl is at number 2. So the name for substituent 2-methyl, not 5-methyl. Okay, 5-methyl is not the smallest substituent. Rule number 3, designate the location of the substituent. The substituent with its number is placed in front of parent's name. Number is separated from words by a hyphen. Okay, so we already know the longest continuous chain, 6 carbon, and the name for parent chain is hexane. And then we already locate the number of substituent, number 2. Okay, number 2 is the smallest number for substituent. And then we want to write the name for this compound. So the name is 2-methyl-hexane. Okay, we have a number there. Number and words is separated by a hyphen, dash. And word we have to make sure it is no space between. No, what happened to more? Okay. Let's highlight. Okay, make sure there is no space between word and word. Okay, 2-methyl-hexane. Okay, this is the rule number 3. Okay, and then rule number 4. Use prefixes di, tri, tetra, and so on if the same substituent appears more than once. Commas are used to separate numbers from each other. For example, okay, remember Rule number one, the longest continuous chain, 1, 2, 3, 4, will have a 4 carbon. So the parent's name is butane. And then we can see that the substituent at carbon number 2 and number 3. Okay, substituent, and the name for substituent is methyl. We have at carbon number 2 and number 3. Then because we have two substituent appear more than once, so if we give the name is 2-methyl, 3-methyl butane, that's wrong. We have to um, we have to use di, yeah, prefix di. So 2 comma d 2 comma 3 hyphen, because number and words, okay, hyphen dimethyl. Well, we know that methyl, we have a 2-methyl there, dimethyl butane. Okay, if we don't use the prefixes, then the name would be very very long. Okay, for example, for the structure that has a lot of substituent, so the name should be very very long. So we use prefixes, so the name becomes more easy for us to write or read it. Rule number 5: arrange the substituent in alphabetical order by assigning small numbers as possible. In alphabetizing, the prefixes di, tri, tetra, sec, and third are ignored except for iso and neo. Okay, di, tri not included in alphabetizing. Okay, we don't take it as account in alphabetizing. Okay, for example, okay, remember rule number one: the longest continuous chain, 1, 2, 3, 4, 5, 6, hexane, and then make sure that the substituent got the smallest number, and the smallest number is 224. Okay, 224. If we count from right to left, the substituent at carbon number 355, 355. Okay, 355, and 224. Okay, 224 is more 224 is smaller compared to 355, right? Okay. And then the parent's name hexane, all right, parent name hexane. Substituent, we have a 2-methyl there, and 2-methyl, okay, 2 at carbon number 2 we have methyl, at carbon number 2 we have methyl, and at carbon number 4 we have ethyl. All right, ethyl. Now we want to make it a name. Remember that arrange the substituent in alphabetical order. We have a E here, E N M, E N M. Okay, E N M. Jadi A B C D E F G H I J K L M N O P. Okay, E. E is the first. So the name is 4-ethyl 2,2-dimethyl hexane. All right, 4-ethyl according to alphabetical order. If you don't remember, you just remember back in your school. A B C D E F G. Yeah, A B C D E F G H I J K. Oh, okay, this one. All right, now it's okay. After this, we can take a break. Okay, for this first, which the longest continuation, 1, 2, 3, 4, 5, 6. Okay, if I try to find 1, 2, 3, 4, 5, 6. Okay, we have a lot of way to, okay, but we just want to write the name for this compound. Okay, here we have at carbon number 2 we have methyl. Carbon number 3 we have isopropyl. Remember, this is isopropyl. We have a three carbon, only 2 isomers, propyl and isopropyl. All right. For 4 carbon, we have 4 isomer, four carbon, four isomer, which is butyl, isobutyl, sec-butyl, and third-butyl. Okay. And at carbon number 5, we have methyl, and it's become 3 isopropyl. Okay, why 3 isopropyl? Because in isopropyl, I, uh, we take I, no, we don't take M here. No, we don't take D here. Diameter is not count in alphabetical order, but for iso and neo, I is we count it as a in alphabetical order. That's why A B C D E F G H I J K L M N M. Okay, so the name is 3 isopropyl 2,5-dimethyl hexane. So now is 30 minutes already. So and Teacher Gong,
Oh, thank you, Cikgu Shahnon. So we will have a
Teacher
break.
Gong.
Berikutan pengumuman penutupan sekolah sehingga akhir persekolahan. Pengajaran dan pembelajaran secara home-based learning tetap diteruskan. Oleh itu, kami di Akademi YouTuber menyediakan tuition online percuma pertama di Malaysia dari prasekolah hinggalah ke sekolah menengah dengan kerjasama e-didik Malaysia dan Kelab Guru Malaysia. Kenapa bayar jika anda boleh dapat percuma? Bermula percuma, selamanya akan percuma. Manfaatkan peluang yang ada. Jangan tunggu lagi, sertailah sekarang. Untuk maklumat lanjut, layari www.academyyoutuber.com.
Dibawakan kepada anda oleh Akademi YouTuber.
Welcome back, student. Before we continue, I will give you the next passcode. Okay, so the next passcode is 56. 56. I repeat, 56. Okay, Cikgu Shahnon, you can continue.
Okay, thank you, Teacher Vivilau. I forgot that Teacher Vivilau as a moderator. I thought Teacher Kong, sorry. Okay. And then, oops, what happened to my... Okay, because of, as I said, the name is 3-isopropyl because of I. Not because of I, not because of P, okay, I, isopropyl. And then we and M. Okay, some important notes here. When two substituents are present on the same carbon atom, use that number twice. Okay, use the number twice. For example, we have a hexane here, 1, 2, 3, 4, 5, 6 hexane, and at carbon number 3, and at carbon number 3, we have a methyl and ethyl. Okay, we have to use the number twice, right? So the name is 3-ethyl, 3-methyl hexane. Okay, E according to alphabetical order. Okay, E and then methyl. 3-ethyl, 3-methyl. We cannot use 3,3. 3,3 ethyl methyl hexane. No, cannot. That's wrong. Like this. Who knows? We have a 3,3 and then ethyl methyl hexane. Okay, cannot. 3,3 only for same substituent. For example, 3,3 dimethyl. That's one okay. That's one okay. Okay. Note number 2. When two chains of equal length compete for selection, okay, choose the change with the greater number of substituent. Okay, choose the change with the greater number of substituent, like this. First, we have to find the longest continuous change. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, we have 7 carbon, and look at number, the color blue, 1, 2, 3, 4, 5, 6. Also 7 consists of 7 carbon. All right. Now this compound compete for name with a greater number of substituent. If you look at number, okay, if we choose the red one, okay, the red one, 1, 2, 3, 4, 5, 6, 7, the this one, number 2, where is number 2? This one, 1. Oops, I think I should change the color. Yeah. Okay. 1, 3, add carbon number 3, and then this is number 5, and this is number 4, like this. Okay. What happened to my color? Okay. Okay, this is substituent. Okay, this is substituent for the first name of the structure. I color with what color there? Okay, yellow. Yellow. We have 4 substituent, 3 methyl and 1 propyl. Okay, and look at this. 1, 2, 3, 4. The blue color. For the blue color, let me erase this one first. Okay, there's this one, and then to color this one. Okay, the blue color. Okay, this is number 1, the substituent. Oops. Highlight. Okay, this is number 1, number 2, right, and then number 3. All right. Okay. Can you see? Only has 3 substituent. At carbon number 2 and number 3 methyl, and at carbon number 4 it has a 4. It has a sec butyl. So according to this rules, when 2 change of equal length compete for selection, we have to choose the change with the greater number of substituent. Of course, we will choose 2,3,5 trimethyl 4-propyl heptane, greater number of substituent. It has 4 substituent. Okay, if you choose color, the blue color there, only 3 substituent. So we have to choose the greater number of substituent. Okay, and then note number 3. When branchings occur at an equal distance from either end of the longest change, choose the name that gives the lowest number at the first point of difference. Okay, look at this. 1, 2, 3, 4, 5, 6, hexane. Okay, the red in color. If we name this compound according to this number, 2,3,5 trimethyl hexane, right? Okay, if you choose the blue one, 1, 2, 3, 4, 5, 6, the name should be 2,4,5 trimethyl hexane. Okay, all the same. The name trimethyl hexane, okay, trimethyl hexane, but the difference only on the number. We have 235 and 245. Okay, and the first difference is here of number number 3 and what happened to my pen? number 3 and number 4. This is the first point of difference. Okay, the first point of difference, we can see that 3 is smaller number than number 4. That's why we will choose 2,3,5 trimethylhexane. If you choose 2,4,5 trimethyl, you got a wrong answer. Okay, the low number at the first point of difference. Okay, the name for this structure or this compound is 2,3,5 trimethylhexane. Okay, now we go to the nomenclature of cycloalkene. Cycloalkenes are saturated hydrocarbon with general formula is C6H2N. Okay, this is for cyclohexane. As we can see, the general formula, the difference between alkane, only 2 hydrogen. Okay, only 2 hydrogen. For linear alkane, CnH2n plus 2, right? For cycloalkane, CnH2n. And then all the bond in cycloalkane are single bond, right? Because of saturated hydrocarbon, and cycloalkane have ring, of course lah. The name also cyclic. Okay, ring. Cyclic mean ring. Some example of cycloalkane are given. Okay, in the table below. Okay, it start from 3 carbon. Okay, 2 carbon cannot form cyclic. Okay, cannot form 2. So for hydrocarbon, for cyclic alkane, it start from 3 carbon. 3 carbon, we have a cyclopropane. Just add cyclo in front of propane, cyclopropane. And usually we will use, for cyclic, we will use skeletal structure. Okay, skeletal structure. We don't use expanded. We don't use condensed structure. Okay, usually, and actually, the ring, for the ring alkane or for cyclic alkane, the best to describe them in skeletal structure, right? We have cyclopropane, cyclobutane, cyclopentane, cyclohexane, and cycloheptane. Not easy to write. Okay, cycloheptane, because of the seven carbon, and when we try to make it cyclics, not easy. Even me, I I don't know how to write the cyclopentane. No, cycloheptane, right? Cycloheptane. And then, okay, cycloalkene with substituent. Okay, now we have here. Okay, let me see my. Okay, now color. Okay, this one. This is cycloalkane, and name for this cycloalkane we already know is cyclopropane. Okay, this is cyclopropane. Now we have substituent here. Substituent, we have substituent, and the name and the name for substituent is methyl. We just where it is all okay, and the name for this structure is a methyl cyclopropane. Okay, methyl cyclopropane. The second one, ethyl cyclohexane. Okay, ethyl cyclohexane. And the third one, okay, since only one substituent, no need to number it. Okay, if you put one methyl cyclopropane, no, there is not the proper name for cyclic alkane with substituent, right? Because only one. If you put at any point of carbon, if let's say I want to write like this, and I want to put methyl here. Okay, methyl here. Huh? The name still methylpropane. Okay, let's say I want to change to here. The name is still methylpropane. That's why no need for us to add number for this cycloalkene. If we only has one substituent. But if we have two substituent, then we have add number for this name of cycloalkene. Okay, the name is 1-ethyl 2-methyl cyclohexane. Okay, this is cyclohexane, and then at carbon number 1 we has a methyl. Okay, what happened is if I write the name is okay, actually we have many choices here. Maybe the name is like this: 2-ethyl 1-methyl cyclohexane. Okay, maybe the name is 1-methyl, okay, and 2-ethyl cyclohexane. Okay, maybe we have a lot of choices here, but the correct name for the structure is only 1-ethyl and 2-methyl, because first the smallest number is 1 and 2. Okay, we only can see 1 and 2 number, right? This one also correct and correct. If your number is 1-6, that is totally wrong. If 1-6, okay, that is totally wrong. If we choose 1/2, okay, that's okay. But we have to follow the rules that um, the E, according to alphabetical order, E must be written first and followed by M. Okay, that's one. So this one we can eliminate 1-methyl, 2-ethyl. We can eliminate. All right, but now we compete 1-ethyl and 2-methyl, and the winner is 1-ethyl because this is it get the smallest number. The E is according to alphabetical order, yes, and it's get the smallest number. Okay, here E got the number 2. Cannot. The E, which is according to alphabetical order, and then it's got the smallest number. So the name for this structure or compound is 1-ethyl 2-methyl cyclohexane. I think today I talk a lot. Okay. Okay, now where is the eraser? Okay, this. Okay. 1-ethyl, of course, we reject. 1-ethyl, 1-6, we reject because that's not the smallest number. But if we have 1-2 for methyl and ethyl, and then we have to consider so many things, and then the correct name for this structure is 1-ethyl 2-methyl cyclohexane. All right, let me see the okay, and then okay, now we have a what we call it exercise. Because I can see here we only has 2 students. 2 students. Only 2. Okay, give IUPAC name for structure A. Okay, follow the first rule of IUPAC name. Try to find the longest continuous chain. 1, 2, 3, 4, 5, 6, 7. Okay, if I follow this, okay, you can see my cursor. Okay, this one 7. Okay, if I follow this one, 1, 2, 3, 4, 5, 6, 7. Okay, also 7. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I got 8. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Okay, now the choice is 1, 2, 3, 4, 5, 6, 7, 8. Octane, octane. This is the longest continuous change, and then we have to consider how many substituent and the smallest number for substituent. Okay, a lot of job we have to do with this structure. Okay, let's see, and it's compete actually. Compete with this one. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay, we can see that it's compete. Which one? Okay, the first one, I have to find the longest continuation, with a lot of number of substituent. Okay, let me choose this one first. So this is substituent number 1. This is number 2, and then number 3, number 4. Okay, I have 4 substituent. If I follow from here, from I'm star here, from here to star here. Okay, I have 4 substituent. Okay, what about if I start from here? How many? Okay, okay. Okay, if I start from here, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Okay, only 3, right? So obviously that the the first one that is, oh, erase all the ink. The first one, this one, and then okay, let's say I choose this carbon as a number 1. This is number 2, number 1, number 2, number 3, number 4, number 5, number 6, 7, 8. Okay, if I choose this one, so the substituent at carbon number 2, okay, I just write here 2, 3, 2, 3. Why I write like this? Because I want to know the smallest substituent. 2, 3, and then 6 here, and 7. Okay, if I follow this route, and if I follow from 8 to 1, the number would be 2 and 3, 2, 3, 1, 2, 3, 4, 5, 6, also 6, and then 7. Wow, it has the same number of substituent. This is very good. This is very good. 2, 3, 6, 7. Same number for substituent. So which one? Okay, and then I look at this one. This one is methyl at carbon number 2. This one, methyl M. If I follow this route at carbon number 2, also methyl. Okay, good. And if I follow here at number 3, I have ethyl. Ethyl. And if I follow from 876, the substituent at carbon number 2 is methyl. So clear here that I have to follow the E. That one is according to alphabetical order. Okay, at number 3, I have E, ethyl. If I follow this route at carbon number 3, I have M, methyl. So this one is the correct name that I have to choose. Okay, and the name is okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay, a lot of methyl here, 3 methyl, okay, and then ethyl. So the name is 3-ethyl, 3-ethyl, and then 2, 6, 7, and then hyphen trimethyl, methyl, methyl, and it is octane. Octane. Wow. Oops. We still have a 4 minute more to go, so I have a lot of structure to be written. Okay, so the name for the structure is 3-ethyl 267 trimethyl octane. All right. Okay, this one. This one, this is mid it pentane. This is cyclopentane. Okay, the parent's name for this structure is cyclopentane, and here remember that the smallest number for substituent, number 1 and number 3. Okay, this is the smallest number, whether it is from here to here, and name for the substituent is ethyl, and name for the substituent. Okay, can you see we have 3 carbon there, 1, 2, 3. If 3 carbon, we only has 2 isomer. Number 1 we call it propyl, number 2 is isopropyl. Of course, this is isopropyl. Okay, isopropyl, according to propyl, according to alphabetical order, E, A, B, C, D, E, F, G, H, I. Okay, E first. Jadi E must get number 1. Must get number 1. Okay. 1 ethyl, 3 isopropyl, cyclopentane. Oh, quite a long name. Okay, 2 minutes more to go. Okay, I think only one. I will write only one structure from question number 2. Write structure for the name below. Okay, write structure trans isopropyl. Okay, first we look at here. We have a trans there. And cycloheptane. First, you have to draw cyclopentane, heptane, mean it propen hex hep. This is a structure that I don't know how to write the structure. Heptane, 7 carbon. Oh, 1, 2, 3. I don't know how to. Okay, number 1, number 2, number 3, number 4, number 5. Wow, 7 already. Okay, 7. But the structure, where is my eraser? The structure is not perfect. Okay, now 7 already. And then at carbon number 1, we have isopropyl. I just choose any point of carbon here to be number 1. For example, I choose 1, 2, 3, 1, 2, 3, maybe here lah, here, because I have to choose the right one, because for trans we have to make it like this, up and down. The line should be up and down, up and down. Okay, because actually when the cyclics means the cyclics we have up and down, the substituent up and down. Isopropyl, 3 carbon. Let's say I put it here like this. This is isopropyl, and here is a hydrogen. This is hydrogen. I want to make it trans. Trans mean opposite. The hydrogen opposite, and also here we have a methyl. So methyl should be here. Yeah, this is methyl here, and here carbon, hydrogen. Okay, this is trans because hydrogen here, one of the hydrogen, if we look at this plane of like this is plane plane of cyclic. Okay, here we will have isopropyl, and here we will have a methyl, and hydrogen should be here. Okay, like that. So this is trans because of opposite of hydrogen or opposite of isopropyl and methyl. Okay, I think it is already 1 hour. So Teacher Vivilau.
Thank you. Okay, thank you, Cikgu Shahnon. Okay, with God's grace, we are done with today's session. We have learned a lot from Cikgu Shahnon about alkanes. Congratulations to those who are able to follow our session from the beginning till the end. And thank you very much, Cikgu Shahnon, for such an interesting lesson. Please check the checkbox for the certificate link. Please off the live chat button and click subscribe button if you haven't. This is to show your appreciation to Cikgu Shahnon for giving you a free lesson today. Don't forget to click the bell button too, so you won't miss out any new videos and live classes from Cikgu Shahnon. If you like today's class, then please click like and share it to your social media friends. Let's share the knowledge you received today with them. Sharing is caring, right? Okay, so I will give you the last parts code. So it's 36. I repeat, 36. So once again, I would like to thank you, Cikgu Shahnon, for the interesting lesson. Thank you also to Teacher Kong and Teacher Tang for being with us today. I think that's all for now. See you in another session. Goodbye, everyone. Have a nice weekend.
Berita
Tuisyen online percuma. Tuisyen online percuma. Layari www.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata ganjaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik.